Hey there, it's Jason Gorman from Codemanship with a video about legacy code for Java programmers. Legacy code is code that is in operation, so it's code that people are using. Very often businesses are relying on it. That is expensive and risky to change, often so expensive and so risky that they don't dare change it. They just typically, fix bugs and do that kind of low-level maintenance stuff. And these systems can become a millstone around a business's neck. They can hold a business back from being able to innovate and change their products and services because the software they're relying on is too difficult to change. What makes it so difficult to change? Well, usually it's our inability to test it quickly. So as we're making changes to legacy code, that testing feedback loop is often so long. Maybe we're testing it manually, or we have a slow running suite of system tests that we're relying on that might take hours to run. And therefore we're in the situation where as we're changing the code, we may be breaking it and we might find out hours later or days later or weeks later, or we might not know until it reaches production quite often. And then the cost of fixing those bugs is much higher. And that means that teams that are working on legacy code very often pretty much spend all of their time and all of their money just fixing bugs because that's all there's time to do. So I'm going to recommend a book now. I'm going to do a video at some point about recommended books for Codecraft, but I just want to introduce this book early. It's the only book that I'm aware of on the subject of changing legacy code. It's called Working Effectively with Legacy Code by Michael Feathers. And in a lot of detail, it describes processes and ideas and principles for making changes to legacy code safely and economically. And Michael, in his book, I think has quite a neat, very simple definition of what he means by legacy code. He means code that does not have fast-running automated tests. So if we were to break it, it might be a long time before we find out. And that's what really makes code so expensive and risky to change, so easy to break. Excuse me. So unsurprisingly, in his book, Michael's focus is on getting fast-running unit tests around legacy code before we make changes to it. And that's the process that I'm going to be demonstrating in this video. So I'm going to describe the algorithm to you first, and then we'll have a look at it. So I've got some code here for a video library that prices video rentals based on the IMDb rating of that movie. So for high-rated movies, we charge more. For low-rated movies, we charge less. So there's a bit of pricing logic inside this class here. And we've been asked by the business to make a change to this pricing logic. We'd like to do that safely, which means we'd like to get unit tests around this code so that if we break it, we know. But the problem is, the thing that makes this legacy code is there are no automated tests at the moment, or there are no fast-running automated tests, I should say. So my first priority would be to get tests somewhere around this code in order to be able to change it safely and to refactor it and everything else I need to do. So here's Michael's sort of algorithm, if you like. I'm going to summarize it very quickly. There's a lot more to it than this, but so the algorithm goes like this. First, you identify what Michael calls the change point. That's the code that we'll need to change in order for us to make this change to the logic. So this class here, pricer, is our change point. This is the code we want to change. Then we identify what Michael calls the inflection point. Some people call it the test point, which is the interfaces around this code, not necessarily the interface of pricer itself, perhaps the interface of something that's using pricer, where if we were to write tests around that and we were to break this code, one of those tests would fail. They would catch it there. Typically, we're looking for interfaces that we don't think are going to change much. So stable interfaces, so that when we've written our unit tests, we're not going to have to be constantly rewriting them. So we're looking for those key interfaces within the system where we think, well, the stuff behind this might change. We might refactor the design inside this. But I think this is probably going to stay the same. Now, there's a bit of a clue as to what the inflection point might be here. I have rigged up a little sort of command line test harness here for little, let's call them system tests, for a rental class. So rental uses the pricer. If we take a look at that. And I don't think this rental interface is going to change much. And if I were to write tests around this, and this were wrong, then if I were to break the pricer, it would show up here. So I'm going to choose this as my test point or my inflection point. So step one, we identify the change point, what code needs to change, and then we identify the interfaces or the classes or the modules around that code, maybe that use that, might even be the UI itself, where if we were to write tests there and we were to break that code that we're changing, then it would show up there. So that would be the best place to write the tests. And we're looking for those interfaces that are going to be fairly stable, so we're not constantly changing them. And most applications, when you look inside, will have those kind of interfaces where they're not going to change rapidly. Then, very importantly, we need to break any dependencies that would be stopping us from writing unit tests for our rental here. And here we can probably very clearly see this code here. What's happening here is every time we ask for a price for a video, we've embedded the code here. We've hard-coded visiting an API on the web, visiting a web service. And we don't want to do that in our unit tests. So I would like to have a stub that returns the information that we're getting from this, in this case, this JSON string. I would like to write a stub for that, and that means I need to be able to swap this implementation code here with something that can be dependency injected. So what I'm going to need to do first of all, let's just check that everything is working. So because of the architecture of this legacy system, I need to package this because I'm actually going to be testing the jar file directly to begin with. So it's all part of, I've got to build it, I've got to test it, it's all part of the process at this point. And I've got a little batch file, let's take a look at this little batch file here, that's using that command line app, and it's taking in a list of IMDb APIs, and it's calculating rental information, including price, for all three of these. So this is the system test that I'm running. As you see, it takes over a second to run. So the build time is about 3 or 4 seconds, and then it takes about a second to run this test. You could probably imagine if this was millions of lines of code and potentially tens of thousands of test cases, then this would be a major, major headache. Okay, so it looks as if it's working. That's good. We're getting our rentals back, and they look good to me. So let's start refactoring. First of all, let's get this code in its own method. Let's call that fetch movie info. That's what we're doing. Okay, so far so good. And now I've just done a refactoring there, and you will find that opinions differ on this. There are some people who say, well, if you use an automated refactoring tool, it's guaranteed not to break the code. Now, I've yet to come across a set of automated refactorings that were that reliable. So I'm super, super cautious. I'm actually going to run my slow running system tests again. Now, it may be that you don't even have system tests, that you're having to test this manually, but I do find from experience it is a good idea to maybe not as frequently as you would do if you had unit tests, but still on a relatively regular basis, keep retesting your software, even if that means you have to build it and run it and click the buttons yourself, just to get some assurance that you're not breaking it. So some testing needs to go on, and I find the more cautious I am, the easier and the simpler and the more straightforward this process is. Okay, so we've got a method that does the work, and what I want to do is I want to put this method on its own object. Let's first of all imagine the object we want to create. So I'm going to be kind of extracting a class here. I'm going to create a new class. Let's call it movie info. Let's add that to my Git session. And then what I'm going to do is I'm going to do a couple of refactorings here. And then I'm going to change the signature of this method to add a parameter for this movie info object. Just call it info and give it a default value of, well, a new one will be good. So there's an instance there to move this method to. Okay, let's do that. And I'm going to do one more refactoring and then I'm going to retest. I'm going to be a little adventurous here. So what I want to do, so I want to move fetch movie info to the info object. And an easy way to do that in IntelliJ would be to convert it to an instance method, and it gives us a choice of which instance, which object to attach it to. Let's attach it to the movie info instance. Okay, lovely. Now, let's rebuild this and retest it. Ooh, build's taking a long time now. So yeah, this is starting to hurt, but that's fine. It will at first. Better safe than sorry, I say. Okay, that all seems to be working. Now what we want to do in our ultimate plan, that's the object that we're going to end up injecting. We want to make this injectable. So let's, first of all, actually, let's get into the whole instance thing here. Static methods generally are a bad idea when it comes to stubbing and mocking and writing a unit test. Code that uses a lot of static methods tends to be much harder to unit test. So I'm not a big fan of them. So let's make this an instance method as well. Okay. And I think at that point I'm going to rebuild and retest. So you can probably see at this point why I would much rather have a suite of fast-running unit tests and not have to go through all of this process. There we go, still working, lovely. Okay, and what we're going to do is let's turn this into a field, and we're going to instantiate this field inside the constructor. As you'll see in a minute, let's call that info as before. Okay, and again, rebuild and retest. So I'm being super, super cautious here, but I have found from bitter experience, it is usually cheaper and quicker to take more care as you go. So even if you're using automated refactoring tools, don't bank on them not messing up. Don't bank on that. Okay, so now we have a constructor. And what we can do is we can pass this into the constructor. So let's introduce that as a parameter. Okay. And again, rebuild and retest. So I just want you to, in your mind's eye, imagine this build takes a minute and my system tests take an hour to run. So now we wouldn't necessarily run them all. Of course, we might run a small subset of them, but it's important to be safe. So find a way. There's always a way. Okay. That's built. Let's retest it. Okay, all good. So now our info object is being passed in. So if I wanted to, I could stub that to return a title, a movie title, and a rating for that particular test case based on my system test cases. But we're not quite done yet. So we said the inflection point was not pricing, but actually this thing, the rental. So we need to kind of rinse and repeat. Our pricer object needs to be passed into rental, injected into rental from the outside, so that when we're writing a unit test for the rental object, we can stub it at that point. So let's rinse and repeat. So I'm going to introduce a parameter for that. Actually, no, let's not do it as a parameter for that. Let's kind of follow the convention here. Let's do it as a field in the constructor. Yep, that's it. And rebuild. I hope you're getting bored watching these builds. That's the whole point of this video. It is, if you don't have fast running unit tests at hand, it can be a major pain in the you-know-what. Okay. And certainly not scalable. Let's retest that. Okay, now what we're going to do, okay, is have this injected. Into our rental object, so it now knows nothing about movie info, which is good. Has less dependencies, and let's rebuild it. Okay, and let's retest it. Okay, now when we look at our little test harness here, you can see Movie info is being injected into the pricer. The pricer is being injected into the rental. So we're constructing the call stack here a bit like Russian dolls. So whereas before the call stack was hard-coded inside those classes, so each class knew which implementation it was talking to, either because it was creating that object or invoking a static method on a class. And what we've done now is we've made all of those dependencies swappable. And it's a bit like Russian dolls. So you know, a smaller doll is put, you know, into a bigger doll, which is then put in an even bigger doll. And that's kind of how we construct call stacks from the outside, from above, if you like. And this is the essence of what we call inversion of control, whereas the flow of those calls was determined by each of those objects in a hard-coded way before. Now the actual flow of our call stack, which object is talking to which actual object, is determined by the ultimate client code. It's determined on the outside, and it's all pieced together. It's all plugged together like Russian dolls. So that's the kind of style of design we're going for. And we would say that this is inherently more unit testable. I could now replace that with a stub for movie info, a class that inherits from that, or I could extract an interface for movie info to make it even more abstract and have an implementation of that inside here, and then turn up my program class here into an actual JUnit test, which is what I'm going to do now. I'm just going to pause this video just to prove it, and I'm going to convert my program here into a JUnit test. So what I've done here is I've created a JUnit test with 3 test cases, one for each of those ratings cases. So we've got an average rated movie, we've got a high rated movie and a low rated movie. And because we're actually injecting the movie info object into the pricer, which is being injected into the rental, now then when we look and see down the bottom here, we've got this method called stub movie info, which actually creates a stub using Mockito in this case of our movie info object, which returns a minimal hard-coded JSON string with whatever rating we tell it to return, basically. Which means we can test what happens when the ratings change to the prices without actually connecting to the IMDb API. So these tests run, rather than having to wait for it to build and then running all our system tests, it's pretty speedy now. It's a very speedy process, and that's going to speed everything up. It's going to make it much, much easier now to make the change that I need to make. So let's go back to Michael's process. Step 1, you identify the change point or change points, the parts of the code that need to change. Step 2 is we identify the inflection points or the test points, and these are the interfaces around the change points where we'd want to write fast-running unit tests. Step 3, we break any dependencies that are stopping us from writing fast-running unit tests, usually by dependency injection. And step 4, then, we write the tests. So we write the tests, and then we can safely make the change that we've been asked to make. The change in this case is we've added a new test case, essentially. So we've got high-rated movies that get a premium price. We have standard rated movies and low rated movies. And now the business is saying, oh, we should charge another £1, so that's £5.95 for classic movies. Classic movies are movies they define as having an IMDb rating of more than 8, or I should say 8 or more. So in a nice, because we've got unit tests around this now, we can, in a nice test-driven way, add another test for a classic movie. Right. Classic movie is, let's call it a super premium price. Okay, and so we're in good TDD territory here. So if you watch my TDD videos, I start by writing my test assertion first. So we're saying that this should cost £5.95. Let's imagine we have a rental object. We want to get the video price for that rental. And then we work backwards from there. So I'm going to write a test that fails, and then we're going to make that test pass. So there's our rental. That's a double, so we need to specify a margin of error there, a delta. Rental. So our rental needs a new pricer, and our pricer needs some way of getting movie information, and that's where we use our stub. So let's stub it with a rating of 8. And, there's another... Does it come before or after? Yeah, the IMDb. So you'll notice that the IMDb, because this is all stubbed now, we're not actually fetching real movie information. It doesn't actually matter what the IMDb rating is. We can pass any old nonsense in there, and that, as long as it's a string, it will work fine. Because that's the way that my stub is set up. So any string, basically, we can pass as the IMDb rating when we fetch the movie info. So there, we've got, let's just put that on a new line there to make it a bit more readable. So we got now hopefully a test that fails in true proper TDD fashion, and that represents the change that the business wants us to make. Let's just check why it's failing. Should be failing, yeah, because the price is wrong. So then we go in and we make the change nice and safely, because we've got a test around this now. I think, okay, how are we going to do this? And less than 8. Then we're going to add £2 to the price. That's a simple way of doing it for now. Let's rerun our test. So we make the change easy, basically. We make it safe to make the change, because we've got these fast-running unit tests, and then we make the easy change. So that was that. And you might have said, well, we could have just gone in and made that change, and that would have been fine. The danger is when we go noodling around in this code that we end up breaking it and we don't realize. But also, moving forward, that doesn't bias anything for the future. What I've got here is I've not just made the business change that I needed to make. In this case, it was a very small change. I've not just made the business change that I needed to make. I've made it safely, so we can pretty confident the code is still working. But also look at what I've added to the code now. I've added some unit tests. So with each change at the business that the customer asks us to make, we add more unit tests, and our test coverage, our test assurance starts to go up. So we start change after change after change, day after day, week after week, month after month. The number of fast-running unit tests starts to go up. More and more our code can be changed and refactored safely. And we've also done some useful refactoring now. For example, if we wanted to change where we get the movie information from, maybe not from IMDb, but maybe from Metacritic or Rotten Tomatoes, we've introduced a flex point into the design where we could specifically do that. So we've made our design more flexible, more easier to change, more modular. There's the word I'm looking for, more modular for the future. So over time, as we add more and more fast-running unit testers and we refactor more and more of the code, we tend to find that the code that was expensive and risky to change becomes less expensive and less risky to change, until eventually the code base, a legacy code base, can kind of be rehabilitated and become a going concern again. The business can start getting ambitious and asking for stuff. They can start making plans for the future. Imagine that. Plans for the future. So we don't have, this is a bit of a warning really, we don't have like a refactoring phase where we stop development for a sprint or for 6 weeks, or for in the case of one client for 1 year, and speculatively refactor. We refactor and add tests specifically for making changes and making them safely. But as we do that, think of it as a bit like paying the legacy code tax. As we pay that legacy code off, we start to find that it becomes less and less legacy. It becomes easier and easier to change and safer to change for ourselves and other developers in the future. But that's not the end of Michael's process. There's one more step. If we take a look around in our code here, let's, for example, take a look at our pricer. There's still other things. There's still too much going on here, isn't there? This code doesn't really belong here. This isn't about pricing logic either. So the final step in Michael's algorithm, in his process for changing legacy code, is while you're in there, now that we've got tests around this and we can have some confidence that we're not going to break it, clean up a bit. It's called the Boy Scout rule. The rule in the Boy Scouts when they go camping is that they should leave the campsite cleaner than they found it. Similar kind of thing here. We leave the code cleaner than when we found it. Now, we've made some improvements, but we could also maybe extract this into its own method, or maybe create an object that does this, that uses the movie info. So we don't see any kind of nonsense about JSON strings or that kind of thing in this. So while we're here, we do more. Let's just do one, just to illustrate. We do more refactorings. No, cannot reform because there are multiple. Yes. So we would need to maybe create the video up there. So that refactoring is a little more complicated than I thought it was going to be, but you get my drift. We can do more refactoring when we're in here. We can rename things, extract more methods, make things easier and simpler. All of these if statements here, I can see these growing and growing. So this is starting to look like a nasty bit of conditional code that we might want to refactor into something a bit more dynamic. So while you're here, just invest a bit more time, now that we've got those fast running tests, to do a bit of easy refactoring, to leave the campsite, to leave the code base or that part of the code cleaner than you found it. And over time, as we chip away at it, the code will get easier and easier to change as the test coverage builds up and as the code gets cleaner. And that's how you change legacy code.